Yes, Assalamu alaikum students. This time we are meeting again. I want to discuss with you the lecture number 7. It is actually equations which are reducible to Clairaut's form. Before this, we did the Clairaut's equation, how we solve Clairaut's equation, what is Clairaut's equation. Then finally you come to know whenever we come across a Clairaut's differential equation, its solution is simply got by replacing P by C. You get the solution. Now in certain cases, if a differential equation can be reduced to Clairaut's form by change of variables. Sometimes I write here, sometimes a given differential equation involving P, say it is dy by dx. P can be dv by du. When v is your dependent variable, u is independent variable. I have already discussed that in previous lecture. It can be P as dr by d theta. When r is your dependent variable, theta is independent variable. It is not necessarily P should be dy by dx. If it is unmentioned dy by dx, we assumed here, if it involves P is equal to dy by dx, a given differential equation involving this sometimes can be reduced to Clairaut's form by change of variables. With change of variables method we reduce the equation into Clairaut's form, but not each and every equation. Sometimes some equations can be reduced to Clairaut's form. So I will give you some tips which substitution, which change of variable you can use here. Number 1, these are the tips that you can use, tips for reducing the given differential equation which is not directly Clairaut's. We want to see can it be reduced into Clairaut's form. We have some tips here. Number 1 is, if given equation involves terms like y square, 2px, 2py, etc., what we do is we have the suitable substitution. We put v is equal to y square, say. This gives you dv by dx is equal to 2y dy by dx. This gives you dv by dx is equal to 2y p. Then you find out the value of p and use this value of p in the given differential equation. Let us see, it can be resolved in this, reduced into Clairaut's form in some cases. This is number 1. If equation involves x square term, p by 2x sometimes extra, then we put u is equal to x square, change of variables. In some books you may see here capital Y is equal to small y square. Here you can write capital X is equal to small x square. You can go that way also. Here you have this du by dy you can use is equal to 2x dx by dy. You can go this way, then this is 1 by p and you go ahead. This is 2 steps. Well, third point I will give you, sometimes it involves both. If the given equation involves third point is, if given equation involves terms like x square and y square. What we do is we put change of variables. U is equal to x square, v is equal to y square. Here we write this du is 2x dx. Here you write dv is 2y dy, so that you can get 2y dy by 2x dx is dv by du. I am dividing here. This is y by x. This is your what? P is equal to dv by du. Then you write p is equal to x by y dv by du. This is also the third tip. If it involves both x square and y square term, then the suitable change of variables will be u is equal to x square, v is equal to y square. We go this way, in that way. Well, in some cases, fourth point I will write, if given equation involves terms like EAX, EBY or only EX, EY, then suitable substitution is, suitable change of variables is, we take u is equal to e raised power ax, v is equal to e raised power by. Here I will get du is equal to e raised power ax a dx. Here I will get dv is equal to e raised power by b dy. Differentiating both sides independently, or you can differentiate here with respect to y, this with respect to x. This is also the theorem. You have done it in previous class. If we have u is equal to f of x, we can write sometimes du is equal to f of x dx. Okay, so these are four tips. If I come across the differential equations involving p which are not directly Clairaut's form, but we want to see can we reduce them into Clairaut's form, we follow these four steps. There are some more steps. Let us now concentrate on these four steps. Let me share with you a question so that you will come to know how we shall go. This is 7th lecture that we are doing on this Clairaut's form. Let me take a question here from the book. It is y is equal to 2px plus yp square. Solve. Y is equal to 2px plus py square. Y is equal to 2px plus yp square. Yp square. This differential equation, if you see, it is not a Clairaut's, because Clairaut says it should be y is equal to px plus some function of p. It involves y, here 2px and so on. According to previous tip, we can put here v is equal to, let us put v is equal to y square. Let us see, by putting v is equal to y square, what we get. It is dv by dy is equal to, I will differentiate with respect to x here, dv by dx is 2y dy by dx. V dv by dx 2y, y is a function of x, it is dy by dx. So you can write dv by dx is 2y. This is your p, because here p stands for dy by dx. From this you can get p. What is p? Your p will be 1 by 2y into dv by dx. you have got this p. Okay, let us see what happens using this p, using p in equation number 1. What is this? It is y is equal to 2x, the value of p you will use 1 by 2y into dv by dx, then plus y. What is your p square? It is 1 by 2y dv by dx square. On simplification, it gives y is equal to x by y dv by dx plus 1 by y goes, it is 1 by 4y dv by dx square. Let us simplify it here. Well, this on simplification will be now, if I multiply both sides by y, this is y square, multiplying both sides by y, it is your x dv by dx, okay, plus 1 by 4, it is dv by dx square. Now what is your y square? You put v is equal to y square, so this is your v is equal to x dv by dx plus 1 by 4 dv by dx square. Do you see? It is a Clairaut. Why it is Clairaut? If we put here, suppose I will make the substitution here, dv by dx is equal to p dash a. If I replace dv by dx by p dash, what happens? This is my v is equal to p dash x plus 1 by 4 p dash square. Now you see, you have, instead of dy by dx, you have dv by dx. V is your dependent variable and x is independent variable. Okay, you do not, if you write the corresponding Clairaut form. What is the corresponding Clairaut form for this? When we have p is equal to dy by dx, do you remember? When we have p is equal to dy by dx, what is the Clairaut form? Y is equal to px. Y is their dependent variable, x is independent variable, p stands for dy by dx, y is equal to px plus some function of p. Here it is also, this is your v. If you write the Clairaut form for this, it should be v is equal to p dash, this is your x, plus some function of p. Now isn't this your Clairaut form? V is equal to p dash x plus some function of p. It is this phi of p. So it is a Clairaut form. So what is the solution? So solution is now you have to, it is the beauty of the Clairaut differential equation. Why we name it Clairaut differential equation? Otherwise we have already done it in the previous lecture number 2nd or 3rd. We have done it. Y is equal to, when y is a function of x and p, how to solve it. There we did not give it the name Clairaut. Here we give it a name Clairaut. It is also the y as a function of x and p, but it has a peculiar property, a beauty it has. When it is a Clairaut form, we write the solution directly. When it is a when it takes the Clairaut form, we write it a solution directly. What is the solution? We replace p or p dash, whatever we denote by this, by a arbitrarily constant. So what is solution? So solution is v is equal to, it is c x plus 1 by 4 c square. But v is not your own, v was for substitution. This is y square is equal to cx plus 1 by 4 c square. This is the solution of given differential equation. Given differential equation solution. This is how we use it here. Tip number 1, we I said there, if we find the terms like this y square or 2py, we go like this. Let me take one more example to make the things clear to you. I will take one more question I want to discuss with you. Px minus y, x minus py. It is solve the differential equation px minus y into y, px minus y. It is px minus y, x minus py. X minus py, very important question, is equal to, perhaps it is 2p, is equal to 2p. Px minus y into x minus py is equal to 2p. We want to solve this differential equation. Now you look this. Can we reduce it to Clairaut's form? It involves actually x square y square terms. How? If we multiply this, x square term gets involved, y into y square terms gets involved. Both x square and y square is involved. Tip number second that I gave you. When the differential equation involving p involves x square y square is not directly Clairaut's, we try to reduce it. If it is possible, not always possible to reduce. We try to see, whether it can be resolved, this reduce it to Clairaut's form. So we take the substitution here. It involves x square y square. I will go this way. Let me put u is equal to x square, v is equal to y square. Note this differential equation involves both x square and y square terms. Let us see what is this now. This you can write it is du is equal to 2x dx. This way you can also go dv is equal to 2y dy. Okay. Now if you divide these by dividing the two, this gives you 2y dy by 2x dx is dv by du. What I did here, I divided 2y dy by this. Corresponding sides I am dividing. This by this is this by this. Division, corresponding division. Well, this gives y by x, dy by dx is dv by du. This is your y by x, this is your p is equal to dv by du. That gives you p is x by y into dv by du. This is the value of p. You have got p in this way. Now let us use this p in first equation. Using p in equation number 1. Using p in equation number 1, what we get? Let us use the value of p there. Well, this is x into value of p is x by y dv by du minus y as it is into x minus value of p is x by y dv by du, x by y dv by du, value of p into y. Then here it is 2 value of p x by y dv by du. Let me simplify this. This gives you x square dv by du minus y square by y. This gives you this y and y goes you can write 1 minus dv by du. X is out. This is 2 x by y dv by du. Do you follow? It is simply I am replacing p by what? The value we got here. It is just simplification. Okay. Now you can get rid of this y and even this x also. This gives you x square dv by du, it is du, minus y square into 1 minus dv by du is equal to twice dv by du. Now what happens? My u is actually what? X square. My v is what? Y square. I can use this x square as u dv by du minus y square. Yes, y square is also v. This is v. This I can write 1 minus dv by du is equal to twice dv by du. Now what we have to do, we have to just simplify this. We will simplify this now. This is u dv by du, multiply this, minus u dv by du square, then minus v plus v dv by du is twice dv by du. Let me simplify this. Now let us see, can it get reduced into Clairaut's form? Okay. Okay, we write this setup here. We replace now. We will replace dv by du. Let us replace it by p dash. Let me denote this by p dash. So this implies your differential equation is now u p dash minus u p dash square minus v plus v, it is p dash is equal to 2 p dash. Okay, let me connect these two. You can write here v common, it is p dash minus 1. Take these two, let us take this to this side, it is u p dash square minus u p dash plus 2 p dash. I have connected v term, taking v out, it is p dash minus 1 on the left side, and other terms I transpose to right side. This goes right side is positive, this is negative, and this is your plus 2 p dash. This is v p dash minus 1 is equal to, taking u common, it is p dash square minus p dash plus 2 p dash. You can write this v, it is p dash minus 1 is equal to u times p common, it is p dash minus 1 also here plus 2 p dash. Dividing both sides by p dash minus 1, this will be v is equal to up plus 2 p dash by p dash minus 1. Now what is this? Your p dash was dv by du. What is the Clairaut's equation, corresponding Clairaut's equation for this? It is v is equal to p dash u plus some function of p dash. Now this is a Clairaut's equation. V is equal to p dash u. This is some function of what? P dash. So it is a Clairaut's. It is Clairaut's equation, differential equation. So what is solution? So solution will be V is equal to, solution is V is equal to, it is U, E dash is C plus 2C by C dash minus 1. C minus 1. C minus 1. So solution is V is equal to, but V is your y square. So it is y square is equal to C x square plus 2C by C minus 1. This is the solution of this differential equation. And we could convert it into Clairaut's differential equation by a substitution. U is equal to x square and V is equal to y square. And this has transformed into the Clairaut's differential equation. Is it? So when it is the Clairaut's differential equation, so we can directly write out. So this is the beauty of the this Clairaut's differential equation. We replace this P dash by this C. This is the solution of the differential equation. Now let us have, I have given you some tips. Where to put U is equal to x square only, where to put V is equal to y square only, where to put both U x square, V y square when it involves x square, y square. And now finally I told you if it involves e raised power ax, e raised power by, or only e raised power x, this e raised power x, b raised power y in the differential equation, how we proceed. For that I will take one more application. Let me have one more application. This is the application which you find in almost all the books. This application, this is a common application that we take here. It is a solve the differential equation e raised to power 3x. Solve differential equation e raised to power 3x into p minus 1. E raised to power 3x p minus 1 plus p cube e raised power 2y is equal to 0. It is e raised power 3x p minus 1 plus p cube e raised power 2y is equal to 0. This is the differential equation. It is e raised power 2y. Where you have, as usual, your p is here dy by dx as usual. Now it involves e raised power ax, e raised power by, or e raised power 3x, e raised power 2x. Let us go this way. Let us put make the variable, this change of variable substitution, suitable substitution that I have told you. Put u is equal to e raised power x, and v we put e raised power y. By differential rule, you will write this is d u is equal to e raised power x dx, because derivative of e raised power x. It is dv is equal to e raised power y dy. By dividing, this gives e raised power y dy by e raised power x dx is equal to dv by du. dv by du. Now this is your v, this is your v by u. Then dy by dx is equal to dv by du. So you get v by u. This is your p, given p is dv by du. So from this you get p is equal to u upon v. U upon v, it will go here, dv by du. dv by du. I have simplified this. I have found out the value of p here in terms of u and v, dv by du. Now I will be using it in equation number 1. Using this in equation number 1, when you use this in equation number 1, what you get, let us use it here. Then this is your e raised to power 3x. When you put e raised power x as u, this will be u cube. Then your p is this. This is u by v, dv by du minus 1, then plus p cube is u by v dv by du cube, u by v dv by du cube e raised power 2y minus v square is equal to 0. Let me simplify this and let us see does it get converted into this Clairaut's form or not. This you can write, this is your u cube u by v dv by du minus 1, then this is plus u cube by v cube dv by du cube v square equal to 0. You can even take u cube common. This gives u by v dv by du minus 1, u cube is out, then plus this is 1 by v because v square and v cube is 1 by v, u cube is out, this you can write dv by du cube is equal to 0, but u cube is not equal to 0 because u cube is u is our e raised power x is not 0. This gives u by v dv by du minus 1 plus 1 by v dv by du whole cube is equal to 0. Let us put dv by du is equal to say p dash. When we put this p dash, let us see can it get converted into Clairaut's form or not. Well, we take v here, Clairaut LCM. This is your u, your dv by du you put p dash. This is u p dash minus v plus this is p dash cube is equal to 0. Look here again, I have taken v LCM. This is u dv by du, that means p dash minus v plus p dash cube. Okay, this is okay. This means u p dash minus v plus p dash cube is 0. Okay, do you follow me? I am making the substitution. U is equal to e raised power x and v is equal to e raised power y, because this differential equation involved what? E raised power 2x, e raised power 3x, e raised power 2y. Accordingly, I have given you the tip. When you want to convert the differential equation into Clairaut's form, we go on these variables, this application. This gives v is equal to u p dash plus p dash cube. Now what is this? It is a Clairaut's equation. It is Clairaut's differential equation, because why? Your p dash is dv by du. It is your dependent variable. So when you write the Clairaut's form, it should be v is equal to p dash u. It is v is equal to p dash u and some function of p dash. Here you should not have u, you should not have v. Constant is immaterial. Whether it involves some constant or not, plus some constant or multiply some constant with this, that does not matter. But it should not involve here u and v. So it is a Clairaut's. It is a Clairaut's differential equation. So what is solution? Solution will be, it is v is equal to u c plus c cube. This is the solution. But your v is e raised to power y is equal to c e raised to power x plus c cube. this is the solution of this differential equation. So we have given you some questions where you are in a position to convert the differential equation into Clairaut's form. This is known as equation is reducible to Clairaut's form, and then we can write the solution directly because we know what is the solution, how we write the solution of the Clairaut's differential equation. You can have some more problem. You can do it. Now you are in a position to convert this. Suppose you have x square. If you have a question like this, x square into y minus px, y minus px is p square y. Here also it involves x square. You can take here u is equal to x square, and you can go by v is equal to y square. You see, you can convert this also, this Clairaut's differential equation, v is equal to y square, and you can do such questions also. And with this I conclude the Clairaut's differential equation. I have started the lectures on this from the equation is solvable for p, then equation is where we can separate y as a single side, one side explicitly, and write y function of x and p. Then another method we did when we write x as a function of y and p, how to solve it. Then when x is absent, only p is a function of y, or y is a function of p, and then y is this absent, so the equation will involve only x and p. We write then when x is a function of p or p is a function of x, how we solve. Finally we come to Clairaut's differential equation. What is the Clairaut's differential equation? How we solve it? There we give also idea about singular solution. But note, when you write the singular solution, you don't add their constant of integration c. If you eliminate c from the factor which does not involve derivative, which does not involve dp by dx or something, which does not involve derivative, you eliminate p from other factor other than the factor which does not involve derivative. There you will do one thing, you will not add the constant of integration c. That is known as the singular solution. Then we come finally how we reduce the differential equation into Clairaut's form. It is equation is reducible to Clairaut's form. With this I conclude this, and stay safe. We are this time actually facing the second COVID wave. It is a very dangerous wave, and you should take care, and we will be meeting you next. Thank you very much.